Assalamu alaikum students. Now we'll be discussing some of the important problems on distance and displacement, as we have discussed the brief concept of the same in the previous video, in the first part of the mechanics, or I can say in the first part of the kinematics. Now the first question I'll be dealing here, I'll go from the zero level to the advanced level. So suppose a body A, it's moving in a circular path. A body A is moving in a circular path. The starting and final position, or I can say initial position and final position, are the same. It's moving in a circular path and coming back to its own position. Calculate distance and displacement. Find. I'll be touching from very basic level to the advanced level. Some of the problems will be from I.E. Irodo, or some of the problems will be from D.C. Pandey or H.C. Verma. So we'll be discussing the first question. It's very easy. We have to calculate the distance and displacement. As we all know, the distance means the actual path traveled by the body, and the displacement means the shortest distance between the initial and final position. So here the initial and final position are same, so that corresponds that displacement will be automatically equivalent to 0. So we can write here simply displacement will be equivalent to 0. The reason for this is, as we all know, the initial position is equivalent to the final position. Now coming on to the distance, body is starting from the point A and covering a circular distance and coming back to the point A. That means it's covering the circumference of the circle. So secondly, the distance, it will be equivalent to 2 pi r, provided if the circular, this portion is having a radius of r. So distance will be simply equivalent to 2 pi r and the displacement will be equivalent to 0. Note it down fast. Second question. We are having a circular path of radius 1 kilometer. A cyclist starts his journey from the center of this park and goes up to point P, then moves up to point Q and comes back to the point O. So I'm repeating the question. Here we're having a circular path of radius 1 kilometer. A cyclist starts his journey from point O to P, then from P to Q, moving about the arc, then from Q to point O, back to the point O. So the question is telling, find distance and displacement. This is also a very easy question. As we know, the displacement simply means the initial and shortest distance between the initial and final position. The cyclist's initial position is point O and the final position is also point O. So displacement will be simply equivalent to 0. Because the initial and final position are same. There will be no distance between the initial and final position. Now coming on to the distance. The cyclist is starting from the O and coming back to the O. So the distance will be the actual path traversed. So distance is equivalent to, first of all, starting from the O to P, plus arc P to Q, plus back to the O, that's Q to O. This OP, it's 1 kilometer, plus this arc PQ, it's the 1/4 of the circle. That's if the circumference is 2 pi r, this will be 2 pi r divided by 4. That is 2 pi r divided by 4 plus, and OQ, it will be 1. So we'll simply solve this. It will be 1 plus 1, that's 2, plus 2 multiplied by 22 multiplied by the radius is 1, divided by 7 into 4. This is 2 r, 2 11 r, this is 2 and this 2 goes, that is 7 will be the LCM, 7 2 are 14 plus 11, that is 25 by 7 kilometers is the distance. So this question is also very simple. As the initial and final position were same, displacement was equal to 0, and the journey, the path of the whole journey, that's simply the distance, that is from OP plus RPQ plus QP. Simple calculations, and we got the answer as 25 by 7 kilometers. Note it down. Now question number 3, the simple question from the DC Pandey. So first of all, a body is starting at point A and traversing a semicircular path up to point B. This semicircular path is having a radius of 1 meter. The question is telling find a ratio of distance to displacement. So we need to find the ratio of distance and displacement. As we all know, the distance for this, it will be the actual path traveled, and the displacement will be the shortest path. Displacement will be AB and the distance will be AB arc. Okay, so as this distance, we need to calculate the distance and displacement. Distance will be equivalent to 2 pi r whole divided by 2, that's the semicircular arc, circumference of semicircular arc, and the displacement is the shortest distance, that is, if the radius is 1 meter, total diameter, that's twice r. Or I can say r is equivalent to 1, so it will be 1 plus 1, it will be only 2. So this 2 and this 2 goes, the ratio will be pi r by 2. This is the ratio of distance to displacement. Note it down. We are moving on the question 4th. Suppose car is moving 50 meters towards east and after that 25 meters towards west. The question is telling find distance and displacement. So as we all know, distance is simply the actual path traveled by the body. The body is starting from the A point up to B point, covering the distance of 50 meters. After B point, coming to C point, covering the distance of 25 meters. So distance will be this 50 meters plus 25 meters, that is, it will be equivalent to 75 meters. So coming on the next part, that's displacement. Displacement simply means the shortest distance between the initial and final position. This is the initial position of the car. This is the final position of the car. The distance from point A to point C, it will be simply 50 meters because from point A to point B, it's 50 meters minus this 25 meters. So displacement will be equivalent to AC, that will be equivalent to 50 minus 25, that will be equivalent to 25 meters. So displacement is equivalent to 25 meters and the distance is equivalent to 75 meters. As from question 1st to question 4th, we have noticed that displacement is always less than distance. If the path is not straight, displacement is always less than distance. If a path is straight, then only the displacement is equivalent to distance. As we have discussed the same in the first part of the kinematics, that the magnitude of displacement will be always less than or equivalent to distance. Hope you people have got this. After that, coming to the question 5. We are increasing the standard a bit. Suppose a body A travels some distance having the radius r up to B. From A to B, the body is traveling some sort of distance, and we are given the angle subtended at the center, that's 120 degrees. So the question is telling find displacement. Find displacement. So note it down from today onwards. If this type of question, you will see this type of question that in case of displacement, some angle is subtending at the center. So the displacement will be simply the shortest distance between A and B, that's the chord AB. So this chord AB, or I can say this displacement AB, will be always equal to twice r sine of theta by 2. Note down this important formula for this type of questions. So here the theta is 120 degree. So it will be now easy task for us to calculate the displacement, that AB, it will be equivalent to twice R sine of 120 by 2, that is 21 R 260 R, sine 60 is root 3 by 2. This is twice R root 3 by 2, this 2 and this 2 goes, then the displacement will be root 3 R. So the crux point of this type of question is when you have to remember this formula, that's AB is equal to twice R sine theta by 2. So this formula is having a full derivation, but we are not here concerned with the derivations. Simply remember this formula, that in case of the displacement, the angle some sort of angle subtended at the center, we have to use simply directly the formula, that's twice R sine theta by 2. Note down. Now we are having a sixth question. We are having a wheel with a radius R. After one rotation, we're having a wheel with radius R. After one rotation, the wheel is coming here. The point A is at top at both the places because the wheel is fully rotating, it's coming at its own position. We need to calculate the displacement. The question is telling that calculate the displacement. Displacement is simply from A point to A point. So it will be simply, if it is fully rotated, the displacement will be the circumference of the wheel, that's 2 pi R. Now the question can be asked like this also. If the wheel is rotating for a half revolution, calculate the displacement in that case. Now the wheel is not fully rotating, wheel is only rotating for the half revolution. We need to calculate the displacement in that case. Now we will look into this. Suppose we are having an A point here. We have marked a point here on the wheel. Now the wheel is rotating for only a half rotation. So this A point will move up to this point. So here the A point will not be at top, it will be at the bottom. Okay. So this distance will also change because the wheel is only rotating for a half revolution. This will be half the circumference of the, this will be simply, we can say, the circumference of the semicircle, because the wheel is now touching the surface only. Semicircular path is touching, the semicircular portion of the wheel is touching the surface. So this distance will be only pi r. Now we need to calculate here the displacement. Displacement is the distance between the initial and final position. This is your initial position and now this is your final position. This will not be your displacement. Okay, so make sure that pi r, it's not your displacement. This here, the initial position is here A and the final position is here. So we'll be joining the initial and final position. If this distance is twice r and this distance is pi r, we can calculate this distance because here is a tangent, that's it will subtend 90 degree. So the displacement, I can say this is A and A dash. The displacement A and A dash, it will be equivalent to root over, using Pythagoras theorem, hypotenuse square will be equivalent to the perpendicular square plus base square, that is pi r whole square plus twice r whole square. So this will be the required displacement in this case. Hope you people got these 6 questions. These are very easy questions. I touched from the very basic level on the topic of the distance and displacement, from the very basic level to some of the tricky questions of the distance and displacement. Now we'll be shifting on to the next topic, that is regarding the speed and velocity. That will be in the next video. Thank you. If you're having any doubts or queries, the comment box is there and you can contact me on the email ID given in the description box. Thank you.